So today we're going to look more at domain stuff. I had a lot of people on the streets of Liverpool asking me, "Hey MMG, Mr. Math Gentleman, can we get more domain content? I need to learn more about domain. I love learning about domain." So I made a video for today, domain of composite functions. So all I want you guys to do is pause the video and try the do now and play it once you're done. So, looking at number one, what has to happen inside the square root to keep it a real number? Well, inside the square root has to be greater than or equal to 0. So I'm going to set x minus 8 greater than or equal to 0. So my domain, once I solve that, add 8 to both sides. My domain is x has to be greater than or equal to 8. Number 2, is there anything restricting our domain in number 2? Well, it's just going to be a straight line. So it's not vertical and it's not horizontal, so we don't have to think about any special exceptions there. So this domain is going to be all real numbers. Or you could say negative infinity and positive infinity, however you want to say that. Number 3, is there something that can happen in number 3? The top's good. The bottom is x plus 9. We cannot have 0 in the denominator, so I'm going to set the denominator not equal to 0. You get x cannot equal negative 9. So our domain would be all real numbers, but x cannot equal negative 9. And then the final one, number 4, now our radical is not in the numerator like in 1, but it's in the denominator. So it cannot be negative because it's a radical, it's inside the radical, but it also can't be 0. So we just set it greater, x minus 5 greater than 0, and you get x is greater than 5 for our domain. Let's go to the next page. So given that f of x is radical x minus 10, g of x is x plus 4, find f of g of x. So remember, we work from the inside out. So g of x is x plus 4. So I now want to find f of x plus 4. So I plug x plus 4 in for x in f of x. So that would now be radical x plus 4. I always use parentheses just in case. And now we can't do anything inside the parentheses, so we can drop the parentheses. So that would just be x plus 4 minus 10, which is x minus 6. And that's equal to f of g of x. So that's that composite function. And we're going to find the domain of composite functions in the vocab breakdown. So domain of composite functions. The domain of a composite function, f of g of x, is the set of inputs in the domain of g of x that are also in the domain of f of g of x. And there's a reason for that. If you can't plug a number into g of x, say we get something for like g of 1, and this is just an example, I'm not even saying what g of x is. Say g of 1 is no solution. You can't actually plug that in. There's, sorry, it's undefined. I shouldn't say no solution. It's undefined. Then when you plug it into f, an undefined into f, you're not going to get anything. So that's why we first need to check the domain of g of x, or what we're plugging in first. So here is a little steps on how to find the domain of a composite function. If it's f of g of x, you first find the domain of what we're plugging into f, and then you gotta find the composite function, and then you find the domain of the composite function. So we'll go over those for the next one. So, very similar question as above, but we want to find the domain. So the very first thing we have to do is do step 1, which is find the domain of g of x. So if I look at g of x, our domain is x plus 4. It's just a normal straight line. It's going to look like that. So our domain for g of x is all real numbers. Okay, so we're not limiting the domain at all with g of x. So now I need to find f of g of x. What we did above, we found it up here. That was already The square root of x minus 6 equals f of g of x. Now I gotta find the domain of f of g of x. So if I look at f of g of x here, what cannot happen? Well, we can't have a negative inside the radical, or else it's the imaginary number. So I would set x minus 6 greater than or equal to 0. So the domain of the composite function would be x is greater than or equal to 6. And let's just make sure, before we circle that as our answer, let's make sure our domain of g of x was all real numbers, so it's not restricting us at all, other than the x has to be greater than or equal to 6. So that is our domain of f of g of x. Let's go to the next page. So let's do the first one together, and you guys could do like try the next two. So looking at the first one, we first have to find the domain of g of x. So let's look at g of x. Our domain of g of x, well, inside of the square root has to be greater than or equal to 0. If it's less than 0, it's going to be imaginary. So I solve that inequality. I get negative x is greater than or equal to negative 3 when I subtract 3 on both sides. Then we divide both sides by negative 1. And I get x is less than or equal to 3 for my domain of g of x. Now I got to find my composite function. So f of g of x. I plug g of x in for x in f of x. So f of g of x would be radical 3 minus x minus 9. So when I look at this one, is there anything restricting my domain for this composite function? Well, there is. It's the same thing. It's that radical 3 minus x. So that's what we have to look at. So that has to be greater than or equal to 0. So we do the same, honestly, the same thing we just did. You get x is less than or equal to 3. So that's the same thing as our domain for the previous one. So our answer is for g of x, so our domain would just be x is less than or equal to 3. You didn't even really need to show this work right here if you didn't want to, because it was the same thing as right here. You could have just taken it from there. So if you want to try and do the next two by yourself, feel free. Pause the video and play it when you're done. If not, we'll do it. We'll do that right now too. So, so first step, we have to find the domain of the inside first. So the domain of g of x. So g of x is 3x minus 4. That's just going to look something like this. So that domain is all real numbers. Okay, so it's not restricting us at all. Now let's find our composite function f of g of x. So I plug g of x into x in f of x. So that'd be 1 over 3x minus 4 minus 14. And I'm going to simplify that. So that'll be 1. I could drop the parentheses and combine like terms. 3x minus 18 equals f of g of x. So that's my composite function. Now we have to find the domain of f of g of x. So is there anything that's restricting us in the numerator? No, it's just 1. Our denominator can equal 0, so I'm going to set not equal to 0. Solve that equation, and you get x cannot equal 6. So let's go back to g of x. That domain's all real numbers, so nothing restricting us here. We just have x cannot equal 6, so it'll be all real numbers, and x cannot equal 6 for our domain. So for the last one on this page, we are looking for g of f of x. So what domain do we have to look for first? Well, the one we're plugging in is f of x. So we have to look for the domain of f of x first. So looking at f of x, that is the square root of 3x plus 15. What can happen inside the radical? We can't have a negative. So all the numbers we can have is going to result in 3x plus 15 to be greater than or equal to 0. Solve that inequality. You get 3x is greater than or equal to negative 15. Divide both sides by 3. And you get x is greater than or equal to negative 5. So we can only plug numbers in that are negative 5 or greater into f of x. So now let's find our composite function. So let's find g of f of x. So we plug f of x in for g of x. So that would now be g of f of x would equal the square root of 3x plus 15 squared plus 3. And when you do that, we get the square root to cancel. So that'll be 3x plus 15 plus 3. And we combine like terms. We get 3x plus 18. And look at that. That's just a nice line. That is going to have the domain of all real numbers. But we have to consider what we cannot plug into f of x to begin with, because we can't plug in undefined into g of x, because then this is all just going to be undefined. So we have to take into account our domain of what we're plugging into g of x, which is f of x. So we have to make sure we combine these two. And the domain would just be x is greater than or equal to negative 5. Because, and let me show you guys an example of that. Pick a number that is less than negative 5. So a number that's not in our domain. Did I hear a negative 10? So let's plug in negative 10 into f of x. So we would have 3 times negative 10 plus 15. And then you would square root that. So that would be f of negative 10. And that would be equal to, in this case, it's not undefined, it's going to be an imaginary number. That would be radical negative 15, which is really, so f of negative 10 is radical 15i. And for our domain, we need to keep it in a real number, so we can't have an imaginary number. So that when we plug it into g of x, we're going to be using an imaginary number. We can't have that. It has to be a real number. So that's why x has to be greater than or equal to negative 5. If you plug in anything less than it, in this case, you're going to be getting imaginary numbers, which we can't have. It has to be real numbers for a domain. For the last one, feel free if you guys want to pause the video and try it yourself. Feel free. We're going to go over it as well. So very first thing we have to do, find the domain of f of g of x. We have to find the domain of what we're plugging in. So let's find the domain of g of x first. So let's take a look at g of x. G of x is square root of x minus 1. So what has to make, in order to make it real numbers, we have to make x minus 1 greater than or equal to 0, because the domain is all real numbers. Add 1 to both sides. We get x is greater than or equal to 1. So let's keep that in mind. I'm going to highlight that to keep that in mind for later. Next, we need to find our composite functions. That's really what we're worried about. So we'll do f of g of x. And what that is equal to is when you have f of x and you're plugging in g of x. So we're plugging in radical x minus 1 minus 2. So I'm just going to drop the parentheses there. So that is really just 1 over radical x minus 1 minus 2. So you could, if you wanted to, and you're going to see this on the filled out completed notes, you could simplify this so the radical is not in the denominator. I actually think that could be, I know that might be what your teacher did, but Mr. Math Guy would do something different. because I think it's going to save some time. So if we look at our numerator, that's just 1. Okay, so if I'm looking for the domain f of g of x, numerator, we don't have to worry about that. Denominator, we do. And there's a couple things going on in this denominator. One thing is it has a radical. So it has a radical here. I'm only looking at this part of it. So we know that that radical, x minus 1, needs to be greater than or equal to 0. So for this one, you actually did all the work already over here, so you don't need to redo it, but you would just, again, get x is greater than or equal to 1. But what else can't happen? Look at the entire denominator. The entire denominator can't be equal to 0. So we're going to solve it to see when it would equal 0. So it would be radical x minus 1. Add the 2 on both sides. Now we want to get rid of the square root. So we square both sides. You get x minus 1 is not equal to 4. And then add 1 to both sides. You get x cannot equal 5. So in this case, we have to look at multiple kind of restrictions or limitations on our domain. So here, it doesn't matter which one you look at, we have x has to be greater than or equal to 1 from g of x, but also when we plug it in. So like either of those are fine to look at. It's the same thing. And also x cannot equal 5. So there's a couple ways of writing this. We could write an interval notation. So x has to be greater than or equal to 1. It can equal 1. So we use bracket. And then it doesn't go to infinity because it can't equal 5. So go to 5 with parentheses. And then I'll pick up right after 5 again to infinity. That's one way you could write this. Another way you could write this is all real numbers, where x is greater than or equal to 1, and x is not equal to 5. You could write that too. There's a lot of different ways you can write this. So that's it. There's the checkpoint. So I want you guys to pause the video, do these next 3 questions, and we'll go over them when you play the video again. So these should be your answer for the checkpoint. Let's look at number 1 first. Notice the domain of g of x is not restricted at all. It's all real numbers. So when we go to f of g of x, we can just find that domain, and that's going to be our domain. So x is not equal to -1. So it'll be all real numbers such that x is not equal to -1. The next 2, though, I believe, yep, our input function, what we're plugging in to f of x, which is g of x, is restricting our domain a little bit. So here, x has to be less than or equal to 6. But when it also factors in when you do f of g of x. So you end up getting the same thing. So our domain is just x has to be less than or equal to 6. But for the third one, this might be where it plays in the most. We get x cannot equal -3 for the domain of g of x. And then when you plug in f of g of x, you get f of g of x to be 1 over radical x plus 3. Let's just make a quick adjustment here. Why can it not equal 0, even though it says here? I'm going to erase that right here. It cannot equal 0 because it's in the denominator. So it should be just x is greater than -3. So that would just be -3 to infinity. Because we also said x cannot equal -3 here. And it also can't equal -3 here. So it would just be -3 to infinity. That's it for the domain of composite functions. What a thrilling concept.